Hi, my name is Jessica Lowell. I recently completed my master's degree with Dr. Stein in swine nutrition. I'll be talking about comparative digestibility of energy and nutrients in diets fed to gestating sows and growing pigs. Here's the outline for the presentation. I'll start with an introduction, followed by materials and methods. I'll then go over results and discussion with a brief summary of results, and then leave you with some overall conclusions. Previous research from Europe has determined that there are differences in digestibility between gestating sows and growing pigs, and Europe uses two values for energy, one for gestating sows and one for growing pigs. One of the main differences between gestating sows and growing pigs is the sow's superior ability to ferment fibrous material in the hindgut. Use of high-fiber ingredients is increasing in the United States. However, to our knowledge, there are no data comparing energy digestibility of gestating sows to growing pigs from North America. Now I will discuss some factors which influence differences in digestibility and fermentability between gestating sows and growing pigs. The first factor is body weight. As body weight increases, so does intestinal volume and digestive capacity. A second factor is hindgut development. A fully developed hindgut supports a greater microbial mass. Also, fermentative capacity is increased as hindgut development progresses. A third factor which influences differences in digestibility and fermentability between gestating sows and growing pigs is the level of feeding. One of the main differences between gestating sows and growing pigs is the level at which they are fed. Gestating sows are limit-fed, and growing pigs are fed ad libitum. Limit feeding decreases the rate of passage, which causes an increase in absorptive capacity. Finally, a fourth factor is adaptation to the diets. This is especially important when talking about added fiber to the diet. It has been determined that the size of the digestive tract increases with prolonged feeding of fibrous diets. It has also been determined that the microbial population in the hindgut increases with increased levels of fiber in the diet. The objective of this study was to determine if values for apparent total tract digestibility of energy and nutrients and the digestible and metabolizable energy of diets are greater in gestating sows fed 1.5 times maintenance than growing pigs fed 3.4 times maintenance. Moving on to materials and methods, 11 diets were used. 3 diets included cereal grains, corn, wheat, and sorghum. 4 diets contained common protein sources, soybean meal, canola meal, distillers' dried grains with solubles, and low-fat distillers' dried grains with solubles. And the final 4 diets included high-fiber ingredients, corn germ meal, corn bran, wheat middlings, and soybean hulls. And the abbreviations you see here in white will be the same abbreviations used throughout the rest of this presentation. Here is the composition of experimental diets, and I'll take a moment to set up the slide. On the x-axis is diet, and on the y-axis is percent inclusion. The blue represents vitamins and minerals included in each diet at about 3%. The 3 grain diets consisted of corn, wheat, and sorghum, included at about 97% with no added protein sources. Corn was then used as the grain source for the other 8 diets. We used 88 gestating sows, parity 2 to 6, and 88 growing barrows with an average initial body weight of 40 kilograms. The experiment was a randomized complete block design with 8 blocks of 11 sows and 4 blocks of 22 growing pigs, resulting in 8 replicates per treatment. Sows and pigs were housed individually and adapted to their diets for 14 days before they were moved into metabolism crates. Sows were fed at 1.5 times maintenance, and growing pigs were fed at 3.4 times maintenance. Once moved into metabolism crates, they were adapted for 5 days before the first marker was fed, and then feces and urine were collected for 4 days using the marker-to-marker approach. Results were analyzed using the mixed procedure of SAS, we analyzed the 3 grain diets, the 4 protein diets, and the 4 high fiber diets separately from one another. Fixed effects were diet, physiological stage, and diet by stage interaction, with random effect as block. Moving on to results and discussion. First, I will discuss results for the apparent total tract digestibility of crude protein. I will begin with the 3 grain diets, and I will take a moment to set up the slide. On the x-axis is diet, and on the y-axis is unit. The dark orange bars represent gestating sows, and the light orange bars represent growing pigs. The format of the slides will remain the same throughout the rest of this presentation. We observed differences in apparent total tract digestibility of crude protein among all 3 diets. However, overall, gestating sows had greater apparent total tract digestibility of crude protein compared with growing pigs. Now looking at apparent total tract digestibility of crude protein for the 4 protein diets. Again, there were differences among the 4 diets in apparent total tract digestibility of crude protein. However, overall, gestating sows had greater apparent total tract digestibility of crude protein compared with growing pigs. Finally, moving on to the 4 high fiber diets. Again, we observed differences in apparent total tract digestibility of crude protein among all 4 diets. However, overall, gestating sows had greater apparent total tract digestibility of crude protein compared with growing pigs. To summarize results for apparent total tract digestibility of crude protein, gestating sows had greater apparent total tract digestibility of crude protein compared with growing pigs, and this is supported by previous research. Increased digestibility of crude protein could be a result of feeding level. This hypothesis is supported by a previous study by Motor and Stein in 2004. This trial compared digestibility in growing pigs fed at different levels. Results indicated that as feeding level decreased, digestibility was increased. Now I will discuss results for apparent total tract digestibility of NDF. We observed a diet by stage interaction for apparent total tract digestibility of NDF. Gestating sows had greater apparent total tract digestibility of NDF compared with growing pigs for the corn diet. However, gestating sows had decreased apparent total tract digestibility of NDF compared with growing pigs for the wheat diet. Gestating sows and growing pigs did not differ in apparent total tract digestibility of NDF for the sorghum diet. Next, looking at the 4 protein diets, we again observed a diet by stage interaction. Gestating sows had less apparent total tract digestibility of NDF compared with growing pigs for the canola meal diet. However, gestating sows had greater apparent total tract digestibility of NDF compared with growing pigs for the conventional DDGS diet. Gestating sows and growing pigs did not differ in apparent total tract digestibility of NDF for the soybean meal diet or the low-fat DDGS diet. Finally, we also had a diet by stage interaction for the 4 high fiber diets. Gestating sows had greater apparent total tract digestibility of NDF compared with growing pigs for the soybean hulls diet. However, gestating sows and growing pigs did not differ in apparent total tract digestibility of NDF for the corn germ meal diet, the corn bran diet, or the wheat middlings diet. To summarize the results for apparent total tract digestibility of NDF, apparent total tract digestibility of NDF varies between gestating sows and growing pigs. We are not entirely sure what causes this variation. However, previous research by Fernandez and others in 1986 also indicates variation in fiber digestibility between gestating sows and growing pigs. Now I will discuss results for digestible energy on a dry matter basis. First, looking at the 3 grain diets, we observed differences in digestible energy among the 3 diets. However, overall, gestating sows had greater digestible energy compared with growing pigs. Moving on to the 4 protein diets, Digestible energy differed among the 4 diets. However, overall, gestating sows had greater digestible energy compared with growing pigs. We saw a diet by stage interaction for the 4 high-fiber diets. Gestating sows had greater digestible energy on a dry matter basis compared with growing pigs for the wheat middlings diet and the soybean hulls diet. Gestating sows and growing pigs did not differ in digestible energy on a dry matter basis for the corn germ meal diet or the corn bran diet. To summarize results for digestible energy, gestating sows had greater digestible energy compared with growing pigs, and this is supported by previous research. Results for digestible energy indicate that differences are not due to differences in fermentation of fiber. Instead, these differences could be related to differences in digestibility of crude protein and possibly starch. Based on our results, we were able to generate a prediction equation for digestible energy of sows from growing pigs. This equation had relatively good R-squared value and may be used to predict digestible energy for gestating sows from growing pigs. In the future, additional diets and models could be used to verify this equation. Moving on to overall conclusions, apparent total tract digestibility of energy and nutrients and digestible energy and metabolizable energy are greater in gestating sows fed 1.5 times maintenance compared with growing pigs fed 3.4 times maintenance. However, apparent total tract digestibility of ADF and NDF does not differ between gestating sows and growing pigs. With that, I would like to thank both the National Pork Board and Poet Nutrition for their financial support. I would also like to thank the Stein Monogastric Nutrition Lab for all of their help during this research.